Variables that are correlated show some kind of relationship. For example, in an earlier example, we studied how the temperature outside and the number of customers at a froyo shop were related. And we saw that as the temperature increased, the number of customers tended to increase too. Some relationships between variables show a negative slope or a negative relationship. As an example, consider the relationship between earning F's in classes and high school graduation. So you might be able to imagine that as the number of F's increases, so as the number of F's people earn increases, the graduation or on-time graduation rate decreases. So you see a negative association. So think about linear relationships. When the relationship between variables show a line when graphed, there's either a positive slope, a negative slope, a zero slope, or undefined slope. In this section, we'll be rating those relationships on a scale from -1 to 1. And this rating scale is going to be called our R values or our correlation coefficient. In this unit, correlation is a measurement of strength, how powerful the relationship between the two variables is. We measure the correlation strength using a rating called the correlation coefficient, or R. So if the R's value is close to either -1 or 1 over here on the edges of the rating system, the relationship between the variables is very strong. Either a very strong negative relationship or downhill slope, or a very strong positive relationship or uphill slope. If the value is in here closer to 0, that means that there's a weak association between the variables. So if it's on this side of 0, it's very weak in the negative direction. If it's on this side of 0, it's very weak in the positive direction. But if it's at 0, there's no association between the variables. Now, look at graph A. First, decide if the data shows a negative trend, a downhill trend, or a positive trend or an uphill trend. So in this case, I bet you're seeing that it has a downhill trend. That decision, uphill or downhill, will narrow down the answers to 2 choices. So here are our choices. We know that there's a downhill or a negative trend, so we can already eliminate the positive answers. We can eliminate this answer, we can eliminate this answer. Next, decide how much the plotted points look like a line. If the points strongly resemble a line, the R value will be close to either 1 or -1. If the points don't look like a line at all, the R value will be close to 0, and many R values will be somewhere in between. Go through this process for graphs B and C too. Decide if the trend is strong or weak. If the correlation is weak, close to 0, there isn't a clear positive or negative linear relationship. If the correlation is strong, close to 1 or -1, there is a clear linear relationship, a clear line is visible. Be careful not to confuse a slope's steepness with the correlation coefficient. Let's look at 3 graphs that show why. These 3 graphs have regression lines that are exactly the same slope, but they have very different R values. The points on the purple graph on the left side are clearly linear. You can clearly see how they would form a line. Because the points clearly form a line pattern, this relationship has an R value of 0.8, a value that's very close to 1. Look at the red graph in the middle. The red graph in the middle shows a linear pattern. We see it going up in kind of a line, but the linear relationship isn't as easy to see as on this first graph. This is why the R value is lower, 0.5. Now look at the blue graph. On the blue graph on the right, it's harder to tell that there's a positive relationship. It's difficult to guess that there would be a positive line here. That's why the R value is close to 0, with an R value of 0.27. The slope of a line will tell you if your R value is positive or negative. Like these are all positive numbers because the line is going uphill. So you can tell from the slope if your R value will be positive or negative, but the steepness of a line is completely separate from the R value. The R value is about how strong the linear relationship between 2 variables is. A lot like a line, a little bit like a line, or not at all like a line.